And welcome back to Module 2.2.3. In this module, we'll actually calculate the universal soil loss equation, look at some of the components and the changes that we can actually implement and the effect of those changes. All right, so remember from previously, there is an equation that we use, and we are going to calculate the annual soil loss. Again, don't get too hung up on tons per acre or megagrams per hectare. The value is the value. So we are on a farm near Knoxville, Tennessee, on an emery soil with 6% slopes that are 150 feet long. Our management practice is continuous corn, conventional spring plowing and tillage with residues left, no conservation practices. So we will go to our R factor, and we are at about 200. This is Knoxville, Tennessee, and its R factor is 200. We are on an emery silt loam, so our K factor is going to be 0.28. Our slope percent was 6% with a length of 150 feet. So our LS value is 1.07. We had spring till, spring conventional tillage with residues left, and no special conservation practices. So here's our R value, and it's just a multiplication all the way across. So we take our R, multiply by K, our length and our slope, our management practices, and then our erosion control practices. When we multiply that, our T value is going to be 5. We do not meet that threshold. So we need to do something in C and P that is going to help us meet this T value. Remember that A needs to be less than T. So we know that we can't change the R. We can't change the rainfall. We can't change the K, and we can't change the length and the slope. But the things that we can change are the conservation practices, the management and the erosion control practices. So if we were to change, this we can't change. This is the location. We're still going to grow continuous corn, but let's see what happens if we change to no-till with almost 2 tons of our residues being left. And we've implemented contour cropping on 6% slopes. So previously we did spring conventional till with residues left. We have now changed to no-till with 3,000 to 4,000 pounds. So our C factor is now going to decrease by a third, right? So we went from 0.37 to 0.11. So we suspect to get some advantage. We do expect that A value is going to decrease. And just to make sure that we meet the threshold, we're going to add an erosion control practice. And we had 6% slopes, and we were going to do contour cropping. That is going to give us a p-value of 0.50. So now let's go back and plug that in. We cannot change R, K, and LS. When we add in our management practices and our erosion control practices, you can see that we decrease that A value from 22 tons per acre down to almost 3.5 tons, which is inside of our T value. So this is where it becomes important. And so if you go back and look at the table, naturally you would want to do no-till with about 4,500 pounds of residues left, and strip cropping on 1 to 2% slopes. Even right here, this would, even if we did this, what if we had done 6% slopes with strip cropping? We would have reduced that even more. That would have been reduced down to probably, 1.5 tons per acre. So just understanding that the C and the P values are something that we can control, and that is what's going to help reduce that A value, and A needs to be less than T so that we can keep our soils on our property. All right, so, it just kind of makes sense that we, don't want to be digging up our soil or kind of moving it around, doing any earthwork while we're, in the middle of a monsoon. Because we won't be able to get anything done, but then also that we're going to minimize the potential for any kind of erosion. So, we want to keep our soils covered. This is going to be important because that's going to decrease the impact of that rainfall, 18.5 miles per hour. And if we can minimize the impact of that rainfall, we decrease the detachment. So, you might have seen some of these things, at least this kind of straw mesh or mat that you can see along roadsides that they're trying to slow down the movement of that water, riprap as well. Here's a hydro seeder where they're, where they are trying to get some sort of cover on this roadside very quickly so that they can get some root growth and kind of hold that soil together. Next, we've got, just anything that's going to slow that water, anything that's going to slow the movement of that water down and minimize any of that soil that's going to move with it. So maybe retention walls. We've seen this riprap as I drive, and we've probably seen this on roadsides as well. Like, that's the purpose of having those rocks on the sides of those slopes. And I guess we have a lot of that in Tennessee. But I also remember seeing a lot of that in Alabama where they had these steep slopes and they're trying to minimize the water movement or slow the energy of that water that is going to allow that to infiltrate before it gets to, maybe a roadside or starts to move, mudslides. Anything that's going to minimize that water movement. Look, we got a lot of grass waterways here that is going to slow how much that water moves. All right, so now here is your opportunity to calculate the universal soil loss equation. Go ahead and pause the video, perform the calculation. You can go back and look through the slides and see what these values are. And then in a moment, we will see what the A value is for this particular situation. All right, we're ready? So we had an R factor for our Charlotte, North Carolina. This R value was 300. We had an Emery silty clay loam. Our K factor was 28 or 0.28. We went to our table and found the value for our LS at a 4% slope that was 50 feet long. So the LS was 0.38. Our management practice, we had spring chisel with 2,000 pounds of 2,200 pounds of residue left. Our C value was 0.22. And we had strip cropping on slopes of 1 to 2%. And our P value was 0.20. And so the lower the C and the P value, the lower the A value we can suspect. All right, so this is what it will look like on the quiz and the exam. Just a very simple exercise of seek and find, plug and play, multiply, get the answer. All right, so this brings us not only to wind erosion, not so much that we have a lot of this problem anymore, but in the late 20s and the 30s, we had a lot of tillage and a lot of cultivation of these lands. There was not enough rainfall in that area at the time, and we start to have human activity. And if we get the windstorm, as wind moves across these plains with no grass area, then we'll have, we're going to have some wind erosion. Again, like I said, we're not overly focused on that because, for the most part, it's going to be rainfall that is going to move a lot of our soil, but wind does play a role as well. So again, we have the same mechanics as water erosion. Remember, there's a big difference between mechanics and types. But for wind erosion, we have different movements. And so these movements are saltation, we have soil creep, and soil suspension. All right, so we have wind that has some saltation. We get these little bitty bounces, and it's possible that, when we get these bounces that we end up getting some break of that soil particle that can then be kind of put into suspension. The smaller the particle, the greater it can be held in suspension. So we have saltation, we have soil creep, and that's just kind of, sometimes we've seen this, maybe soil will just kind of slither or maybe just kind of flow across, maybe a surface. You get enough wind that kind of keeps that down. It doesn't really pick it up, but we end up hitting some structure and the wind moves that soil up and it is held in suspension. This is kind of what we see around our tractor. All right, so some of the things that are going to affect the wind erosion obviously is going to be the velocity. So the faster the wind, the more we would expect for wind erosion. Turbulence, and so if you start to get movements, some twisting and turning, air does not flow in a laminar pattern or straight. So this is where you start to see like maybe little dust tornadoes. How rough the surface is. So if there's something in the way, like crop residue, we're going to minimize or decrease that erosion because that soil will hit some particle and stop, like a corn stalk. It'll hit that stalk and then stop. Soil properties and vegetation. This ultimately comes down to these two things as to how you can minimize either wind or water erosion. And so for wind erosion, we also have kind of a universal soil loss equation, but it has a couple of different factors in it that are different from the USLE, but they do the same thing. These different components are going to give us an indication of how much soil erosion we will have from wind. We're not going to go over that in this class. We're really mostly concerned about water erosion. But I did want to talk about wind as well, and that you can see the different, kind of like a compare and contrast, some of the things between wind and water erosion. But some of the factors that are going to influence that wind erosion are going to be things like soil moisture. And so if the soil is moist, water is heavy, and so the wind can't pick that soil up, even that little soil particle, because it is heavier than the ability of that wind to pick that up. Tillage is going to influence that because that's going to change our soil structure. And then we want to put barriers around. And like this one took a minute for me to kind of wrap my head around. I never understood why there were lines of trees around fields. I like this didn't make sense to me. I guess prior to being exposed to this, I was like, why are those trees there? It don't make no sense. Why would you put trees there? Why wouldn't you just want to be able to see your whole cornfield? Well, the reason is because the wind would cause havoc or cause some problems in this area where we are operating. So once I saw this, I was like, oh, that makes sense. So if you ever go to build a house, it'd probably be a good idea to put some trees around the property so that you can kind of change the microclimate of your living area. I thought it was just to look pretty, but it actually has some functionality. All right, so these windbreaks are going to have some influence on kind of moving that air or that wind above an area and protecting your crops. So when we're talking about tree windbreaks, we can protect an area that is 10 times their height. So that if we had trees that were 100 feet tall, how much area would we be able to have protected from that wind? 100 foot tall, and we get a 10x coverage area for this crop. Well, 100 times 10 is 1,000. So if we have 100 foot tall trees, we can plant crops up to about 1,000 feet away, and those trees are going to push that wind up before it comes back down 1,000 feet away. For our grass windbreaks, it's not as much. It's more like 5 to 7 feet. So that if we had some grass windbreaks that were 7 feet tall, and we got a 7x protection area, 7 feet times 7x, we would have 50 feet worth of protection. All right, and so we'll see this, maybe you want to plant some crops in between your rows. This has several benefits. You're going to kind of decrease the competition for weeds. Now, you might get some competition from these plants, but for the most part, in this particular situation, most of your nutrients are being supplied and your water being supplied by drip irrigation, but you're getting some protection from the wind. So that wind is going to carry little soil particles that might cut that leaf. These little bitty small nicks in our leaf are going to decrease water holding potential. So we'll get an increase of water loss. Those little small nicks make this crop prone to infection. It's an entry point for bacteria and pathogens to come in. It decreases, basically just the whole plant has this. It's just like you getting cut, right? Like if you had a bunch of little nicks on your skin, that wouldn't go well. You would have to spend more energy to try and recover that. So there are, some extra benefits to having this wind erosion. All right, so that is going to end module 2.2.3. That ends module 2.2, and you can now complete the quiz 2.2. All right, we'll see you in the next module 2.3.